SL Aroda or HC Verma only. Okay. And if you have any kind of doubt in these two books, you can always ask it to me.
Okay.
Okay. So let's have a little recap about the yesterday's class. Yes. First of all, any doubts in the homework question? If there is any kind of doubt, so you people can ask it to me. No doubts. Yes, Region. We can't hear you actually. I think yes.
Yes, sir.
Yes, now we can hear you. Is there any kind of doubt in the homework question, or yeah, I think that you had not done that. That is why. And yes, Sahil, you don't have any doubts in the homework question.
No, sir, I told right. I have done all the homeworks except for the Kirchhoff's law, the last one.
Yes, and rest all you had done. No issues
Yes,
with
those
that.
were just normal resistance. Yes, that was normal. The Kirchhoff's
That
law
was
actually looked
normal.
hard. I haven't solved it yet.
Okay, in the Kirchhoff's law, actually, you need to apply the mathematics. Okay, so
Okay.
you can do that. But in the rest of the questions, I don't think that there is anything such like that you will unable to solve. But still, it's amazing that if you have any no doubts in that, because at my time when I used to solve the questions apart like this, if the 10 questions is given to me, apart at least from this 10, I used to have 4 to 5 doubts. 50% of this used to be of my doubts. Okay, but
Yes, sir.
if you don't have any, so either you have understood everything or maybe you I'll take the best case scenario. Okay, so let's have something that we were discussing in the last class. That is, we had seen starting from the very start beginning. We had seen the combination of the cells. Yes or no? We had seen
Mm.
the combination of the cells. Okay, so let's say that if these are some of the practical cells that I'm connecting over here. Okay, let's say that these are some practical cells that I'm connecting over here. And let's say it is 2 ohm, it is 1 ohm, it is 0.5 ohm. Okay, and let's say that this is 5 volt, this is 2 volt, and this is 3 volt. Okay, and let's say that this time I'm drawing the battery somewhat like this. Okay, and the resistance is like this. So it is, let's say that this is the A point and this is the B point. This is the A point and this is the B point. So what will be this this battery? What will be the voltage of this battery?
So that will be -5, -2.
-5,
So
-2,
-4.
and +3. Okay, that will be
Mm,
-5, -2, and +3. That will comes out to be minus of 4.
-4.
That
Right.
will comes out to be minus of 4. And what will be this resistance? That will be actually the sum of it. So it is actually
Yes.
3.5 ohm.
3.5.
Okay. So this is something that we had seen. Now see that once we had got to this result, we if we want it, so we can actually that we have that much of mind that -4 volt applying like this is equivalent to applying the 4 volt like this and the resistance of 3.5 ohm like this. Okay,
Yeah.
so it is the equivalent one. If we ever reach to one of the configuration, we actually have the tendency of seeing the voltage to be positive. So we'll just invert the batteries and we'll get the answer result to be positive. Okay. And the second thing that we had seen for the parallel one is that this one, and let's say, let me apply this, and let us have this one. Okay. Let it to be 6 volt, the 12 volt, and let it to be 10. Let it to be 8 ohm, 8 volt actually. Okay, and let this to be 2 ohm, 1 ohm, and let it to be 2 ohm only. Okay, so let it be. Now, if I want that instead of this two AB, I want to join the single one, and let it be that I want to join it like this. Okay, so this is R equivalent, this is small r, let it be, and this is E. So how can I calculate this E? Yes, Region, tell me.
Uh, equivalent, you can just calculate by 6 by 2 plus
Will it
whole
be
by
6 by 2 or -6 by 2?
Oh, yeah, minus 6 by 2.
Minus 6 by 2. You have to take care about the sign. Okay,
Yeah,
so minus 6 by 2,
then
then
the plus 12 by
12 by
1,
y, and
then minus 8 by 2.
8 by 2.
And
Okay, 8 by 2. And
yeah,
whole
and
divided by
the 1 by
1 by
2
2
and 1
plus 1 by
plus
1 plus 1
1 by
by
2.
2. Okay, calculate it out that how much we get. This is minus 3 and this is minus 4, minus 7 plus 12. That will reach out to be 5. Yes.
Mm, yeah,
And in the denominator, what will I get? Will I get the 2?
yeah, 2.
Okay, so it will be 5 by 2 volt. So what this EMF will be? EMF E will be actually equal to 5 by 2, or I can write it as 2.5. And what this R will be actually equal to?
It will be 2 only.
1
by
by
5
2.
here.
1 by
Oh,
2,
it
yeah.
is.
R will be equal to 1 by 2. Okay, so is this all okay that how we are doing it?
Yes, sir.
Sorry. So this is something that we had seen, but and I had also told you that these combinations are not going to help us a lot, because see, this is something that we used to get simply by applying the Kirchhoff's law. This if we are doing this thing, so we used to simply get it by applying the Kirchhoff's law. We don't require any kind of equivalent combination, but if we still want it, so we can do it. And I think solving the things in series is very easy. We simply need to sum these things and we used to get the answer. This is somewhat a tedious formula, that is E1 by R1, E2 by R2, E3 by R3, and 1 by R1 plus 1 by R2 plus 1 by R3. So doing the things in the parallel becomes somewhat more calculations comes into that. So that is why I don't recommend to anytime solve this out and get the things. We can actually get the things without even that. But and I had also told you why to do so, because if we simply just substitute this with this equivalent one, with its equivalent resistance and the equivalent, that is the EMF. What is the problem here? That now we are not sure about that what the current is in this branch, what the current is in this branch, what the current is in this branch. So
Yes.
if the question demands us to know about these currents, so we'll never be able to answer it by substituting with its equivalent. We have to go through our the very basic calculations of Kirchhoff's KVL and KCL. Okay, so that is why I had recommended you, if we want to calculate the parameter outside this box, outside this whole box, outside, just a second, outside this whole box, then we can apply this formula of equivalent one and can calculate the things out. But if we want to know about that what is going inside the box, so we can never do. Okay, let me give you a question over it, so that you people should get a better clarity over this thing. Okay, let me get the question for you. Yes, this is the question. uh, yes, yes, got it. Now see what the question says actually over here. Okay, what the question is saying. uh, the circuit is given somewhat like this. The resistance is this, and battery is like this. Okay, and this is this, and this is this, and the battery, whole one, and this is another battery uh, in the reverse manner is. And we are connecting it like this. Okay, it is 10 volt, it is 2 ohm, it is again 10 volt, it is 2 ohm 10 volt, 2 ohm 10 volt, and this is 2 ohm. This is again 2 ohm. This is 10 volt, and this is 2 ohm. The last one, that is 2 ohm and the 10 volt. Okay, you have to calculate the current in this branch, I. Okay, now calculate it. You have to calculate this I.
Mm.
Sorry.
Mm.
Yes, any suggestions for starting this question?
Yeah, we just make a loop, right? So, uh, um, so you can hear me?
Yes, yes, I can hear you. We
Yeah,
can make a loop, but
yeah.
where to make the loop? What
The
do you
10
mean to
volt,
say actually?
like just
Yes, what do
we
you mean to say? The 10 volt,
from
where
10
should
volt,
I choose the loop? The
the
bottom
bottom
one?
right. Yeah, the bottom
You
right.
are saying
Yeah.
that I should mark a current over loop. I can't understand again.
No, just normal things are we
Okay, so what do you want to do actually?
wait. Let me see. So the usual thing, like you take a point and you calculate the voltage and current.
Calculate the voltage and current.
Uh,
So first
yeah,
of all, I need to mark the currents everywhere.
yeah. Yeah, you can mark the current. Yeah,
So this current is already marked I, so I don't
I1.
require to,
Yeah.
and no, I don't require anything. If all, it is already given in the question that this is I, so let it be I only, है ना?
Hmm.
Or you
Yeah.
want it to keep, so keep the both the things to be I1, okay?
No, no,
And this
I
is
is one.
I1, I1, and now it will get divided into further three parts, I2, I3,
So,
and the remaining one.
so we can't just for the three what do you say, three wires in parallel, can we not use the formula and just find E equivalent and R
Yes.
equivalent?
Yes, that is the good thing over here. This question is made for that particular concept. Understood, Rajan? What he's
Hmm.
saying? He's saying, sir, we can see that across these 2 points that I'm marking over here. This, oh, sorry, not this one. This point and this point. What we can see across this point, this is the one parallel combination. This is the another parallel combination of the voltage and the resistance square. Now the one comes and says, sir, what about this? These are the two resistance at the battery. So I say you can substitute actually this 2 ohm and this 2 ohm because they are in series. You can actually substitute them with the 4 ohm and a 10 volt. Substitute in the same way. And then what you will find out that these three are in the parallel combinations of the cell. Is this clear to you?
Yes, sir.
Yes, Region, is this clear to you?
Yeah.
So across this 4 ohm, if I want to mark the A point over here, okay, let me draw it in the same orientation. Uh, okay, let me copy this circuit. Let me copy this circuit, place it over here. Okay, so now what I'm going to do over here, that I'm going to mark this point A here. Okay, let me mark this point A over here and B over here. Okay, that is in the same orientation. Now what I want the combination of the cell to be somewhat like this and a equivalent R of this. Yes, everybody, is this clear to you people?
Yes, sir.
Yes.
And what else will be there in the circuit? 2 ohm, a 10 volt in the opposite of here, that is this, and this one, that is this, and this. Is this clear to you, people?
Yes.
This is 2 ohm. Now, if we are comfortable with this circuit, so we can actually get the answer. Now, see, solving the things in this circuit is much easier as compared to solving the one that the region was saying, that to mark the current individually. Okay, but if the question would have demanded any parameter inside this circuit, inside this loop, then you need to go through that
Yeah.
full-blown equation of the KVL and KCL that the region was suggesting. Okay, so that is the full process. But as we can see that we can work cleverly, that we don't require anything inside that particular thing, so we can actually remove that out. Okay, now see, now apply the things. Okay, so yes, if I had to see the things like this, yes,
So
what
the
will be the
voltage,
hmm,
the voltage,
10 volt.
the voltage sign is wrong. Like it should be like positive on the right side. No?
voltage voltage side is wrong. Voltage sign is no is wrong. It doesn't mean anything. Okay, I can keep the voltage sign in any way. Where you are talking about? You're talking about this, na?
Yeah, yeah,
You're talking about this, na?
yeah, yeah,
Okay, so it doesn't matter actually. If
yeah, yeah.
I would have taken the this sign, so I have to keep all the things with this direction. The positive terminal whose is facing towards A will be taken as positive, and the rest will be taken as
Oh
negative.
yeah.
If
Yeah.
I had taken it in the otherwise, so what will happen? So I will get a negative answer here. Okay. If
Yeah.
this was not true that A is facing the higher side and B is facing the lower side, so what will happen? I'll get the inverted answer. That is of the negative one. So that the equation will itself tell me not need to worry about that. Although that what you are saying is absolutely right, I'll get a negative answer here and see that how I'm getting this negative answer. Okay, so what will be the first thing? That will be 10 divided by 2 plus 2, that is the 4. And I, in fact, minus of 10. Yes or no? For this branch. I'm talking about this branch. Yes or no?
Yes.
Yes.
For the second branch, I'll get minus of again 10. Let me write it
By
like
2.
this. By 2. And for the last branch, I'll again get plus minus of 10 whole divided by this time again 2. Yes or no?
Yes.
And whole divided by the equivalent one, that is 1 by 2 plus 2 plus 1 by 2 plus 1 by 2. Yes or no?
Yes, sir.
So I think first one is minus of 2.5. The second one is minus of 5. Third one is also minus of 5. And whole divided by this is 0.25. And this is 0.5 and 0.5. That will become 1. Not zero point 0.5. Yes. What will be the thing? That is minus of
Minus 10.
12.5 divided by, that is 1.25. Yes or no? Have I done it correctly?
It will be minus of 10, yeah. Final.
Yes. Now you can see that it will be minus of 10 volt. Yes, Rijan, did we got a negative answer here?
Yes, sir.
So what does that mean? That the thing that you were saying is correct. Okay, that the B is facing the higher voltage and A is facing a lower voltage. But as I had drawn the things like this, I have to keep this thing to be minus of 10 volt. Now again for the R equivalent, what will be the R equivalent that I'll get over here?
4
That
by
will be,
5.
I think, 1 by 1.25, है ना?
Yeah.
And that will be equals to 100 by 125, and that will be equal to 4 by 5. Yes. This small RAB will actually be equal to 4 by 5. I think you people had calculated at your notes, so I'm not showing it over here. So that will be actually equal to 4 by 5. Okay. Is this now clear to you people?
Yes, sir.
We can do the further the things of the equivalent, that is the combination of the cell. Can we see that these all are in actually, these all are in actually the series combination of
Yes.
the cells?
So now we
So
can use
we can
Kirchhoff's law.
apply, so okay, but it is better to use the Kirchhoff's law. Okay, it is better
Yeah.
to use the Kirchhoff's law. Now, okay, see, whenever the circuit comes like this, okay, let me make this over here again. Whenever the circuit comes like this, so it's my suggestion to you that invert the sign of the battery immediately. Instead of -10, you have to keep it like this and keep it to be 10 volt. Okay, now apply the Kirchhoff's law, but you can even apply the Kirchhoff's law here as well. Okay, you want to apply it here, just apply it over here. Okay, if you'll apply the Kirchhoff's law over here, from which point you people want to start?
A.
A.
From the A point and want to move like this or in the another way?
This way only.
In this way? Okay, yes,
Mm.
Region, tell me that what will be the equation?
So it will be positive 10.
VA, then
Yeah.
minus of -10.
So
Yeah,
it's
that's
positive only.
a positive.
Okay,
Yeah.
so that will become positive of 10. Okay,
Yeah.
so that will be the thing. Let the I current is there, no? So I had marked it with I. So
Yeah.
the next will be minus of I into 4 by 5,
Yes. And
and
minus of
next will be minus of 2 times of I, and
mm,
minus of 10, and again minus of 10, and again, let me shift you people here, and that will be minus of 10, minus of 10, minus of 2 times of I, and we'll reach to the same point VA.
yes.
Yes or no? And
Yes,
if
sir.
we, just a second, if we would have applied the KVL in this equation, then what we'll get? VA and plus of 10. Immediately we'll get the plus of 10. Can you people see this?
Yes, sir.
Without doing that thing. But ultimately, the both the equations that we are going to get is the same. So again, plus ka 4 by 5 times of, not plus, it will be minus 4 by 5I, minus of 2 times of I, and it will be minus of 10, minus of 10, and minus of 2 times of I will reach to the same point VA. Okay, is this clear to you people?
Yes, sir.
Yes, sir.
VA will be get cancelled out, and I think this 10 is also being cancelled out, this 10 and this 10. Okay, and we'll be left with what will be the I here? Combine the I. So what will be
V
the
25
coefficient
by
of
12.
I?
The
Okay,
coefficient of I will
let
be
me see.
minus 24 here.
That will be 2, 2, 4, and 4
This is
point
same.
4 by 5 plus of 2 is equals to 10. See, have I written it correctly?
Yes.
Okay. I shifted the 10 on another side. So I'll get this. Then I will be equal to, we'll take the 5 here, and the 4 plus 4, 5 is 20. Okay, so it will be this.
Yeah.
And then next it will become 50 by 24. And that will, if we'll
25 by 12.
further 25 by 12 ampere. So is this clear to you people?
Yeah.
So this is how we are getting the current over here. The good thing that you must learn from here, that when to apply and when not to apply. Okay, so this is the thing that we are getting over here. Okay, done.
Yes.
Yes. Now let us see that. Now see, if somebody comes at this point, once we had calculated all the things. Now, if somebody comes and asks you that what is the current in these three branches, that is I1, I2, and I3.
Hmm?
If somebody comes and asks you that what are the current in these branches, so can you people calculate it out?
Yeah. No,
So just
using this
We need to use
in
Kirchhoff's law
whatever the
for.
way, Kirchhoff's law,
Kirchhoff's
but
law.
how will you apply? Like in this circuit again, that you are getting some current, you will mark the currents and all. Are you
Yeah.
going to go through that particular thing?
Uh, that only no, sir. What else?
Hmm?
That only no Kirchhoff's law.
That is the Kirchhoff's law that you can do, But is there any better way of applying so? Because that is something that one may have started it from very initial and will do the same thing that you people are going to do after reaching to this point. So is there no benefit of solving this whole calculation that we had done? The answer is see what you can do further here. In this equivalent circuit, this A and B, actually we can calculate the potential difference between this VA and VB.
Yeah.
We can calculate so. So let us calculate this VAB, that what this VAB will be equal to. Let us say that VA equals to this. Okay, applying this VA and reaching to the point B. Okay, so VA, and then we'll see plus of 10 and minus of I. That what is our I? I was, what was our I? That
25
was
by 12.
25 by 12. So that is 25 by 12 into 4 by 5, and we'll reach to the point VB. Yes or no?
Yes.
Yes.
Now, if we'll do the further calculation, so 5 1s are 5, 5 2s are 12, 5 5s are 25 actually, 4 and 3. So we'll get 10 minus of 5 by 3, that is actually equal to 25 by 3, and VB minus VA will be equals to 25 by 3. Yes or no?
Yes, sir.
Yes.
Okay. Now see, you can use this information here and can calculate the things out. You can use this information here and you can calculate this out. See, we had got this information. Now, how to apply this over here? Let us say that we are calculating this I1 current. So start from VA. Start from VA. VA plus of 10 minus of I1 into 2 will be equal to VB. Yes or no?
Yes.
Now
Yes, sir.
10
Oh,
minus of I1 into 2 is equals to VB minus VA. What was VB minus VA? That is equals to
25.
25 by 3.
Hmm.
So that is 25 by 3 that you can use here. Did you people understood that what I mean to say?
Yeah.
Yes, sir.
And what will it will become? I think that 5 by 6 is coming the I1. Yeah, have I done this correctly? Hmm. 5 by 6 will be the ampere.
So, sir, I2 will also be same here.
Yes, absolutely.
Yeah.
Okay. Now what is we had utilized here? That the symmetry we had utilized. Okay, that I1 is same will be as same as I2. Okay, so what we can say, although even if you do the calculation also, you will get the same answer, but I2 will also be 5 by 6 ampere. It is good that you people had started using the symmetry concept. So I2 equals to 5 by 6. Now for I3, what should I do?
10 minus I3 into 4.
Yes, exactly. We can actually subtract the total current. Okay, so that will become I3 will be actually equal to, we can do the for write the equation for KVL also, but let us give some importance to the KCL as well. So that will be the total current, that is 25 by 12, subtraction of the current that is passing through I1 and I2. So that is 5 by 6 plus of 5 by 6. Okay, so that is nothing but 25 by 12 minus of 10 by 6, I think. And if we'll
Yeah.
multiply the 2 by 2 in the above equation, you will
5 by
get
12.
25, 5 by 12. So we can see that we are getting the I3 current to be 5 by 12. So can you see that we had actually find out the everything. We had actually found out all the parameters over here. So, and
Yes, sir.
now understand that if we would have applied the KVL and KCL, so what would have happened? That we had applied it, how many variables will we have? If we'll apply so, how many variables will we have? First of all, what is the thing that we'll apply it in the closed loop? Okay, if we'll apply it in the closed loop, then what we are going to do? We are going to have the three variables, I1, I2, and I3. Yes or no?
Yes.
Yes.
Okay, you can replace one of the I1, I2, I3 with this I, but ultimately you will have the three equations always. Yes or no?
Yes, sir.
So for those three variables, you have to use the linear algebra concepts of solving the equation simultaneously. So there is a lot of chance of the mistakes. So for this question is actually meant for that particular thing. Is this clear to you people?
Yes, sir.
So that is why we had got particular this thing particularly over here. Okay, now moving on to the another thing, that is the concept of and yes, I had not given you the questions here over the uh, temperature dependence of the resistance. Okay, and I think that that is the easy one. You will always get the values. You need to substitute it in those equations, and you will get the answer. Okay, so I'm just
Okay,
not
sir.
solving the questions over that particular thing. Moving on to the another thing, that is the electrical power. Electrical power. Okay, so what is the electrical power? See, electrical power, you will get it again. See, I'm not writing the definitions and all the things over here. I will just explain you that what it means. Okay, electrical power, it is actually the measure of that at what rate you are utilizing the energy. Okay, for example, let's say that there is something that is giving us let's say it is providing us the 100 joule energy in, let's say, somewhat 50 seconds. Okay, and there is some another source that is providing us the 1000 joule energy in, let's say, the 100 seconds. Okay, so now what is going to happen over here? One one How should one choose that which source is better? Which source is better, this source S1 or this source S2 is better? Which source is actually better one? This source S1 is better or S2 is better? So now see,
Oh,
everybody will come and say, one will say that, see sir, this is providing us the less energy and this is providing us the higher energy. So yes, you are absolutely right, this one is providing the lesser energy, one is providing us the higher energy. But one must question over there that, sir, it is
um,
taking the 50 seconds and this is taking the 100 seconds to provide the energy. So it is providing the energy in fast way, and this is providing the energy in the lower way. So how should we reach to the conclusion that which source is better in terms of power? So that is why we had defined this thing, that is the power. And power is of anything. If you want to calculate the power of anything, so what you have to do, you have to take the ratio of energy supplied divided by the time it takes.
um,
So if you are dividing the power of 1, so what will be the power of 1? That is 100 by 50. And the power of 2 will be 1000 by 100. And what does it mean? It gives the 10 and it gives the 2.
oh,
So what is the thing? And the unit of power is actually the watt. Okay. So this is thing. So that means this is having the power of 2 watt and this is having the power of 10 watt. So this is that will reach to the thing that this source 2 is better because it is providing the 10 watt power, and it is the above one is providing the 2 watt power. What does this power mean? This power mean that we can say that source 1 is providing 2 joule of energy per second, while source 2 is providing 10 joule of energy per second. Is this clear to you people? That this is the
yes,
general
sir.
power that I had explained. Till now, we are not had concerned about anything with the electrical quantities. We are only learning that what the power actually means. So this is how we use to define the power of anything, that how much energy it is providing and how much time it takes while to provide that energy. Okay, so this is called the power. This is how we are uh, giving the thing to explain the power. Now we'll see that how to measure the power of the electrical quantities. How to measure the power of electrical quantities. So write it over here that electrical power will be again nothing but electrical energy divided by time it takes. Time taken. Okay, is this clear to you? Now what it will be? Power is electrical energy is represented by H and it is being represented by the time taken as T. So that is why we used to define the power by H into T. Is this clear to you people?
Yes, sir.
Yes, sir.
Okay. Now, what is electrical energy? Electrical energy, that means its unit will be in joule per second, or equivalently we used to say it as watt. Okay. So what is electrical energy? Electrical energy is actually work done to move a charge I think that will not write this. Okay, so electrical energy, how we are going to define it? We are going to define the electrical energy, that is H is equals to work done. And what it is, how we are going to calculate the work done? We are going to calculate the work done by V into I into T. Okay, it is the thing that how we used to calculate the electrical energy of anything. Okay, work done, you people know it now, that work done
Yes.
can be represented by Q into V. Okay, in the electrostatic
Yeah.
chapter we used to see this. And what this Q is nothing but V into I into T. What is I? I is actually equals to Q by T. So we can actually find out the Q to be equals to I into T. Okay, so this is the thing.
Yes.
And the next thing that we can see over here, that is if we replace anything like V equals to I, what it is, I into R, so it will become I square RT. Heat will become I square RT, and heat will become V square by R into T. Equivalently, if you'll replace the I by V by R, by Ohm's law, we are applying again and again, and we are getting the this result. Okay, so that it will become this. Now we already know about H. Define the power. So the power will be actually can be written as, if we'll use this thing, we'll get the formula to be V into I. And instead of not using the small I, we should always move to the capital I. So power will be equal to V into I. Okay, the equivalent representation of the power is, if we'll use the Ohm's law again, so I is equals to V by R, so it will become V square by R. Or if we'll replace V equals to I into R, so you'll get the power to be I square R. Okay, so these are the things that you can simply move from one to another by using the Ohm's law. Okay, so this is something that we should know. But now understand this power. See, I will always recommend you to use this particular formula. To use this particular formula. Whenever there is any element, okay, let me mark it like this. There is any element inside this box. I don't know about this, that what is it inside it. Okay, and what is happening if it is having a potential drop of V across it, and a I current is passing through it. So what will happen? That it will have a power of V into I. Is this clear to you people?
Yes, sir.
Yes, sir.
It will have a power of V into I always. Okay. Whenever you need to calculate the power, just look at about the voltage across the terminal and the current passing through it. That's it. That's all the sufficient information that you require, and you can do so. Okay, and if it's a resistor, then you can use these particular things. Okay, you can use the Ohm's law further and can simplify the things or to get the other things. Okay, is this clear to you people?
Yes, sir.
Yes, sir.
So this is something that we used to get. And okay, write some more information about it that is sometimes being asked. So commercial unit of power. Yes, what is the commercial unit of power?
What?
That is what?
Kilowatt?
That is commercial unit of power. Commercial unit of power is not a power. Okay, commercial unit of power is not a power, it's energy. It's
Oh,
energy, and it is defined as unit. Is defined as unit. What is unit? The electricity that comes in our house. the bill that we use to give it. So what the thing is written over there, that is unit is being written over here. And what is 1 unit? 1 unit is actually equal to 1 kWh. And 1 kWh is actually the energy. So what is if we convert it into the joule? So what it will be? 1 into kilo. What this K stands for?
Kilo.
That is 1000.
Oh,
Okay.
1000,
Have I
yes.
told you about this or not? Deci, centi, milli, micro, nano, and kilo. Have I told you about this? What this deci stands for? 10 raised to the power minus 1. Centi stands for 10 raised to the power minus 2. Milli stands for 10 raised to the power minus 3. Micro stands for 10 raised to the power minus 6. N stands for the nano, that is 10 raised to the power minus 9. And
9.
kilo stands for 10 raised to the power 3. In whatever way you are doing it, whatever the subject you are studying, these values will always have the same meaning. For example, let me give you 1 kilogram is how many grams?
1000.
1000. This K actually stands for the 1000. You can actually substitute these letters with its equivalent value. K is equivalent to 1000. So that is 10 raised to the power 3. So that becomes 10. Instead of K, I had written what it is. It is 1 into K. Instead of K, I'm writing 10 raised to the power 3 and the G here. Is this clear to you people?
Yes. Yes, sir.
Now tell me, 1 centimeter is how many meters?
10 raised to negative 2.
10 raised to the power negative 2.
Negative 2.
That means 1 by 100 meter. This is something that we used to learn. But even if you replace this centi, what you will get? 1 into 10 raised to the power minus 2 meter.
Yeah.
Is this clear to you people? So this is
Yes.
the actually the something that we can apply anywhere. It doesn't require any kind of restrictions. You can actually substitute this whenever you get the D. You can substitute it with 10 raised to the power minus 1. Whenever you get the C, you can substitute it with 10 raised to the power minus 3. M milli, you can substitute it with 10 raised to the power minus 3. Okay, this is something that you know. Okay, tell me 1 ml is how many liters? We used to learn it
1000.
as 1 by 1000 liter. Yes or no?
Yes.
So actually, even if you replace this small m, what does this milli stands for? Milli stands for 10 raised to the power minus 3. So 1 into 10 raised to the power minus 3 liter. And this is the same thing that we used to learn. Okay, so the important is that you must learn these things. You can learn these things and you can apply it anywhere in any subject, even in the chemistry or wherever it is required. Okay, so kilo stands for, I was here, kilo stands for 1000. And uh, what this R is, how many seconds it is?
Fixing.
Yes, that is 3600. What
Oh,
this watt is actually, what this watt is, watts is 3600 second. And what this watt is actually joule per second. Yes or no?
Yes.
yes.
Because we had seen what is watt. Watt is actually defined as joule per second. Okay, so instead of watt, I'm writing joule per second and like this. Now, what next? You can simply cut this second from second. And what the thing that you will get over here? That is 3600 and 3 more zeros in joule. And in the scientific notation, you can write it as 3.6 into 10 raised to the power 6, I think. Yes. Okay. So 1 unit is actually equals to 3.6 into 10 raised to the power 6 joule. Is this clear to you people?
Yes.
So this is something that you should remember about, and you can actually calculate it out. Okay. Now, like for example, in the above circuit, if I ask you anything, you can calculate it out. How so? Let me ask you that. Okay. Should we do this question only? Uh, mm, Okay, let's do this question for the perspective of this power. Okay, let's analyze the power here in this particular question, because we already had calculated everything, na? So that is why I'm utilizing this over here. Okay, so let's see this. Now, let us say, let me mark the things over here. I think we already have the values now. What is the
Yeah,
value
Yeah.
of I? What is the value of I
25
here?
by 12. 25 by
That
25 by
is
12.
12.
25 by 12 ampere. What is the value of I1?
5 by
5 by
6.
6. 5 by 6 ampere. I2 was also same as 5 by 6. And I3 was 5 by 12, I think. है ना?
Yeah. S-
See it over in your notes now.
So was it 10 by 12 or 5 by 12?
I3 was 5 by 12.
Or 5 by
12.
12, okay.
Okay. I3 was 5 by 12. So we already have this information. So let us utilize it. Because the question can be asked like that, what is the power that is being given? Okay. Now see, let me write some with some color. Let's say P1. Okay. Across every quantity, I'm writing it. Okay. P1. This is P2. For 2 ohm, I'm writing it as P3. For this, P4. This P5. This is P6. This is P7. This is P8. And this is P9. This is P10. And this is P11. Can you see that I had marked the power across every element, either every electrical element, that is the battery as well as the resistors. Okay, yes or no?
Yes, sir.
Yes.
Okay, now let us start from the very initial. Let us see that the P1. Let us see, analyze the solutions. Okay, let me make it a proper question now. Question is calculate power across, calculate power P1 P2, ठीक है, it is going जा रहा है ऐसे ही है, and it is going
Across each
till
element.
P11. Okay, it will reach till 11. So I'm not writing all of them, just understood it. Okay, now let us see that what is the power of 1 P1, how to calculate it out. If you want a power of 1, so what do you want? You want the current passing through 2 ohm multiplied with the voltage of 2 ohm. Is this clear to you people?
Yes, sir.
Yes.
What is the current passing through 2 ohm?
5 by
5 by
12.
12.
That is 5 by 12
12.
into what is the voltage in 2 ohm? In 2 ohm, we don't know right now about. So let us
Yes.
use the Ohm's law. Let us use the Ohm's law. What the Ohm's law says? Ohm's law says if you want to calculate the power, just multiply the current and
Higher
multiply the current and the resistance.
resistance.
So what is the current? That is again 5 by 12. That is the 5 by 12 into resistance. What the resistance is? 2.
2.
Okay. So what the power will become here?
5 by
Let it be 144 only, and it will be 25 to 50. 50. Okay, this is the power given by the P1. Okay, I'm not simplifying it. We can further simplify it with the 2, but I think that this will help us
Yeah.
in
Okay.
further calculations. Okay, so this is the power P1. Okay, now one more question arises here, whether this is the power delivered or the power absorbed. Understood? Two things can happen, that either the element is providing the power or it is absorbing the power. So always remember that resistors always it dissipates the energy. Okay, it always absorbs the power. Okay, what happens that if there is any resistor over here, it can never provide the power. If the I current is passing through it, so it will always dissipate the power. Can you understand this? That this
Yes.
will always dissipate the power. And what is it will dissipate actually the heat. What it will do? It will dissipate the heat, and this heat will be actually equal to I square RT. Okay, this heat will be actually equal to I square RT or V square by RT, or you can say V into I into T. Is this clear to you people?
Yes, sir.
Yes, sir.
And okay, let us see that this So this is what? This is the absorbed one, na? This is the absorbed one. Okay, is this clear to you people?
Yes, sir.
Now calculate the power P2. P2 is the power across the 10 volt. Yes or no?
Yes.
Okay. If this is the 10 volt, so what is the voltage across 10 volt?
And
So, okay, let me write it over here. You have to write the current passing through 10 volt multiplied with voltage across 10 volt. What is the current passing through 10 volt?
5/12.
That is 5 by 12. Into what is the voltage of 10 volt?
10.
That is itself 10. So write it to be 10. So what we'll get over here? We'll get 50 by 12. Yes or no?
Yes.
Yes.
Further multiply it with 12 by 12, I think. Okay, if we'll multiply it with 12 by 12, because this will actually, what will happen that in the end we'll see a nice result. 12 5
Yeah.
is 60, that will become 600 by 144 watt. Yes or no?
Yes, sir.
Yes.
Okay, now tell me that what is happening here, whether this is delivering the power or it is absorbing the power. So how to know that? We had get to know that the resistor always dissipates the power. But what about the voltage source? Does it dissipate the power or absorbs the power? So how to get it? See, if it's a voltage source and from its positive terminal, it is delivering the current. So what is happening? This is actually delivering the power. Okay. And if we ever get the configuration like this, that the current is going into its positive terminal. So what we'll say, it is absorbing the power. Is this clear to you?
Yes, sir.
Now see what is happening with this 10 volt. Yes, Rijan, tell me. It is delivering or absorbing
It's absorbing.
from
Delivering.
its positive terminal. The current is leaving or current is going inside the positive terminal. See, this is the
Uh,
positive terminal, the bigger one.
yeah.
The current is
Oh, yeah. Leaving composite terminal and
leaving.
entering. Yeah.
So what does it mean? That it is delivering this time.
Delivering. Yeah.
This is delivering. Okay. Let us do it
Sir,
for the P3 as well. Yes.
for P1, is it absorbing or
The
dissipating power?
resistors always dissipates the power.
Okay.
Dissipates, see, absorbing, the word absorbing, dissipates is all same. Okay.
Oh,
Absorbing is same as dissipates.
So dissipates means giving it out here.
Yes,
And absorbing
dissipates means
means
wasting the energy.
okay.
Dissipates
Yes.
means wasting the energy. Dissipates mean here the it is wasting the energy. So that is why I had written that it always dissipates the energy, the resistors. Okay, so that is why 50 by 144 was being absorbed actually. Okay, and this P2 was delivering. Now tell me for the P3. Don't you think that from the P3 the same current I3 is passing? So can I mark it as
Yes.
the P1 as well, P1 only? Can I
Yeah.
mark it?
yeah.
Okay. So P3 will be same as 50 by
P1.
144. And again, as it is a resistor, so what we'll say that
Absorb.
it is absorbing. Okay. It is again absorbing. This is the P3. Now let us do it for P4. Let us do it for P4. What the P4 is doing? P4 is delivering or absorbing.
It's delivering.
It is delivering. Okay. So for the P4, current in P4, current in mm, what is it?
5 by
The
6.
voltage of 10 into voltage across the 10 volt. है ना? So what is the current in 10 volt? 5 by
5 by
6.
6.
5 by 6 into 10 is 10, I think. So that will be 50 by 6. Yes or no? In order to make the
Yes.
144 here, what should I multiply? 6 2s are 12, 6 4s are 24,
24.
I think 24
24.
and
Yeah.
24. 24 5s are, I think it's 120, 0 divided by 20, 144.
140.
Yes or no?
Yes.
And again, it is delivering or absorbing? It is
Absorbing.
delivering.
Delivering.
For delivering, you're
delivering.
talking about. Yes, sir. I
You
thought you're
can
talking about
talk
resistor.
about the P4. Okay, so it is a P4,
Yes.
it is delivering. Now P5, calculate it for the P5 as well. So I of 2 ohm into V of 2 ohm. Okay, current is 5 by 6 into, if you want to calculate the value of voltage, so we'll use the formula I into R. I is again 5 by 6 into resistance. What the resistance is? That is the 2 ohm. Yes or no?
Yes.
So will I get 50 by 36?
Yeah.
So what should I multiply here in order to get the 144 here? I think 4. 4 will work.
What?
Yeah.
If we'll multiply the 36 with 4, so will I get 144?
Yeah. Yeah. No. Yeah.
And in the numerator, I'll get 200 by 200. It is delivering or absorbing?
Absorbing.
It is absorbing. Okay. We are marking a lot of things over here. I don't know that whether in the end we'll reach to the conclusion or not. Okay. P6. What will be the
Absorbing.
P6 here? P6 is again P6, that is absorbing, and absorbing or dissipating. I'm repeating it again. It is the same thing.
Yeah.
Okay. So P6, don't you think that P6 and P5 will be same because the same
Yes.
current is passing and the value of resistance is also same? Yes or no?
Yes.
Yes, sir.
So should I mark it as 200 by 144 watt? And again the absorbing. Yes or no?
Yes.
Yes, sir.
Now again, for the calculation of P7, for the calculation of P7. Will it be same as P4 because the same current is passing in the same manner, and it will also be delivering
Yes.
because the I1 and I2 is same, na? So
Yeah.
what will be the P7? It will be same as P4.
Or
P7 is same as P4. That is 1200 by 144. 1200 by 144 watts, and it is again delivering. Yes or no?
Yes.
Now calculate for this 2 ohm, that is the P8. For this P8. For the P8, what is the current I passing through the 2 ohm? Passing through the 2 ohm, and the voltage across the 2 ohm. What is the current passing through the 2 ohm? The I, that is the capital I, that was
uh,
our answer. That is 25 by 12.
25 by 2.
Yeah.
Okay, so that will be
Yes, sir.
25 by 12. Now, in order to calculate the voltage, I should multiply the current with the resistor. So the same current 25 by 12 into resistor 2. Yes or no?
Yes.
Yeah.
Okay, so this is the voltage part that I had calculated. This is the current part I had calculated. Although you can see that it's I square R. Okay, but
Yeah.
I'm not writing it explicitly. Okay, 25 into 25, that is I think 625. Yes or no? And further multiplying
Yeah.
it with 12, that will be 1250 divided by
Yeah.
144. Okay, and it is delivering or absorbing?
Absorbing.
The
It is again absorbing. It's a resistor. Okay, now moving on to the P9. What is P9 over here? That is the voltage across this 10 volt. Okay, so P9 is
Absorbing.
current across the 10 volt into voltage across the 10 volt. So what is the current? That is 25 by 12 into voltage across the 10 volt. What is the voltage across the 10 volt? That will be same
10.
10.
10,
So
10.
it will be 250 by 12. And if we further multiply it with 12 by 12, so we'll get the 144. What we'll get above?
3000.
25 into 12.
3000.
3000. Are you sure about it?
Yeah, I think.
I think 0, 0, 1. Yes, 3000. Yes. We'll get the thing to be 3000 watt. Okay. And what it is? Delivering or absorbing?
Absorbing.
Absorbing.
This time it is absorbing. Okay. So voltage source doesn't mean that it will always deliver. It may absorb. And here you can see that this battery is being charged.
Yeah.
Okay. So now P10, What is the P10 actually? That is voltage across the 10 volt and current across the 10 volt.
Same.
Same
10
thing.
volt. Will it be same? Have you got this? Right? This is the
Yeah.
same thing absorbing and the same current is passing. So it will be again P1000 by 144 watt and again in the absorbing manner. Okay. And now we are very soon going to reach the conclusion, that is P11. P11 will be absorbing and I of 2 ohm into voltage of 2 ohm. I is what is the I? What is the
Same
I?
as P8.
25.
Yeah.
Okay, same as
P8.
P8. Excellent, excellent. P8, the same power is there because the same current is going to pass and the same
Yeah.
resistance is there. So it will be same as P8. And what is the value of P8 that we had calculated? That is 1250 by 144. Okay, this is the what? And what it is? Delivering or absorbing?
Absorbing.
Absorbing, and because it's a resistor. Now say, so now you people are comfortable in calculating the power, and you can tell it that whether it is absorbing or delivering. Yes or no?
Yes, sir.
But do you know that this circuit is it being additionally supplied by any energy? Is there energy additional if I just pack this whole thing? If I pack this whole thing into a box, is there any external source by which I'm providing the energy to this box?
No.
No. So that means the element which are providing the energy will be the one that is absorbing the energy. That is, I mean to say that there are some elements in this box that are providing the energy, and the rest all are absorbing the energy. That means the energy absorbed, that means the power absorbing and the power delivered should be same.
Oh,
Yes or no? It is the
yes.
law of conservation of energy, because we are not
Yeah.
providing any energy to it. So that means the elements which are delivering, because if there is 6 joule energy in the box, so elements can dissipate only 6 joule. They can't dissipate more
Yeah.
than that.
Yeah.
Okay. They can't dissipate. If I am getting that 6 joule is being given is there inside the box and 8 joule is dissipated, how is this possible? Okay. So what we want is that power absorbed should be equal to power delivered. Okay. Power absorbed will be equals to power delivered. Now I don't know that if we had not done any mathematical mistakes, then we'll get this result to be true. Otherwise, there could be mistakes. Okay, so should we take the risk? Should we calculate it?
Yes, sir.
We should calculate it. Okay, let's do see. Let's see that what comes. What is the power absorbing? That is
50
the
by
50 by 144. Okay. Can you people dictate it to me if you had written it over the anywhere?
yes.
Yes.
Yeah.
50
And
by 144 plus what
uh,
is the next power absorbed?
again 50 by 144.
50 by 144 plus
Then 1200 by 144.
1200 by 144 plus
Then 3000 by 144.
3000 by 144 plus
Mm, 1250 by 144.
1250 by 144 plus.
Then again,
Yes,
I
then
think I think that's all right.
that's all. Okay.
Mhm.
Let me see. Absorbing is 125 by 144, 3000 by 144. You had missed this 3000 by 144.
Mhm.
Yes or no?
Oh yeah,
Yes, I will
P9.
have you rechecked
Oh
it
yeah, yeah,
that whether
P9. Yeah,
that
that's
is
the one I missed.
3000 by 144. Okay. And 1250 by 144. There is two 1250 by 144. P8 is also there.
I didn't say that.
P8 is also there. 1250 by 144.
Yes, sir.
And this is delivering 200 by 144. You have people have matlab,
I've not noted it down.
that is 200 by 144, and the P5 is also 200 by 144, and delivered absorb is 50 by 144 and 50 by 144. So how many are there? 50 by 144 and 50 by 144 two times. Then see now, is the thing written correctly? How many are there? There is the 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is there, and delivered should be 1. 3 should be delivered now.
Hmm.
मतलब आप लोगों से सिर्फ इतनी सी चीज नहीं हो रही है. P1 is 50 by 144, and the next
Sir,
thing is
I didn't write it down. That's
P3 is 150 by 144. Then P5 is 200 by 144. This is P5. Okay. And then P6 is also 200 by 144. Then P8 is 1250 by 144. 44. And P9 is 3000 by 144. And the P10 and P11. Okay. I think now we had done it correctly. So sum these up. What it will become? 50, 50, 100. 1200 added to it. That will become 1300.
1,200 total.
Sum the numerators and find the final answer. Everybody.
10,200 by 144.
10,200 and
10,200
10,200
by
divided by
144.
144. This is the power absorbed. Let us
Yeah.
see that what is the power delivered. If we'll find out the power delivered, what it will become? Power
It's supposed to
delivered
be the
will be,
same. So,
yes, it's supposed to be of same, but let's see that whether we are getting it to or not. 1200 by 144, I think that we are not. 144, that is the first power delivered, and then the power delivered is 1200 by again 144. Okay, okay, okay. 24 is 1200 by 144. 44. Yes. Anything left?
uh, 600 is
The
there.
uh,
600 by
delivered na,
144.
where it is
Sir,
the
it's
power
Power to.
P3.
600 by
P2.
144. That is the P2.
Yeah.
600 by 144. 44. So it's not coming
2,000.
out to be the same.
2,400. 3,000.
It's probably
It's
some
coming
one
out to be
extra.
3000 by 144. Yes.
Wait, 1, 2.
Have we done anything in an incorrect manner? Okay, I think that you people should check it out. We'll get the power to be same. Power absorbed and power delivered will be same. Okay, is this clear to you people?
5, 6.
Yes.
Oh, let me count it.
Sir,
1,
can you
2,
just
3,
check
4,
P4?
5, 6, 7, 8, 9. Yes, P4.
Can you know? Just 1 second, sir. I didn't.
No, I think, sir, we took some extra in absorb,
Definitely,
extra. Yeah.
definitely. But what is the extra that we had taken?
Uh, mm.
Let's not waste the time over here. Okay, so check it out at your home and tell me that whether what was the wrong. Okay, but at least we got the idea that how to calculate the power absorbed and the power delivered. Is this clear to you people?
Yes, sir.
So I'm just removing this part of delivered and absorbed from here. Okay, but ultimate goal is that will get the power absorbed and the power delivered to be the same. Okay, so check it out. Okay, other question, other part of let's move on to the next thing. This was the power delivered and power absorbed part. See, now the next part is that if we have a voltage source, okay, and let's say if it's a practical voltage source, it will have a, a small. What we want is that we want the maximum power of it to get delivered. Okay, that means let's say that if we are connecting a element of interest here, that is the R, and we want that the R should get the maximum power. Okay, just a second, let me.
Mm.
Yes, is my voice audible to you people now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so what we want is that this R should got a maximum power. The maximum energy should be get, because what is going to happen, a part that this E is going to deliver, a part of it will get dissipated over this from this R, and a part of it will get dissipated over this R. But what we want is that this is our element of interest. We want that the maximum power should get delivered to R. Maximum power should get delivered to R. Okay, so for to maximize this power, uh, what one will say that, sir, we can actually increase this E. So that is one of the logical way of answering the thing, that we can increase the
Yeah.
E. But don't you think that if you will increasing the E, that is ultimately increasing the cost? That is ultimately increasing the cost. And
First.
if this box is already had arrived to you, it is packed. You can't change anything among E and R. You can only change this R. That is the element of interest. We can only vary this R. We can change the different values of R. Okay. So what is going to happen over here? What should be the value of R should be chosen actually? Okay.
Maximum.
Maximum power should get delivered to R. So in order to that, what is this R you should select? So what the R we should select? So actually, for to do so, uh, first of all, calculate the power across this R. So for to calculate this power, what do you need? You need the current and the voltage, the
Yeah.
current through this R multiplied with voltage across this R. Yes or no?
Yeah.
What the current will be here? E divided by capital R plus the small r. Yes or no?
Yes.
Yeah.
And the for to calculate the voltage, you will multiply this current with the resistor. Yes or no? This is actually the V of R.
Yeah.
Yes.
So what the result we'll get is
Right.
E square divided by capital R plus small r ka whole square into R. Yes or no?
Yes.
Yeah.
Okay. Now what is our aim is to maximize this. To maximize this. In order to maximize this, what this R we should choose. Okay. So see, this is now the mathematics will start, and what you have to do, dp by dr of dr to be equal to 0. This is the concept of maxima minima that we are using here. Have you people completed the calculus,
Yes, sir.
Yeah.
the differentiation, integration
Mm.
in the
Yes.
mathematics? Okay.
Yes.
Yes.
So should I do it over here or should I tell you the final result?
Final
Final
result,
result.
sir. Final result.
Final result you people want? So for to maximize, get the maximum power should get delivered to this R. In order to that, you should choose this R to be equal to this small r. Is this clear to you people? that if we'll choose this, then we'll get the answer. Okay, let me give you a perfect realization of this particular thing. Okay, so let's say that this is the small 2 ohm we are choosing. Let's say this is the 10 volt, and let's say that this is what we can say. Mm, let us choose some value over here. Let us say that this is 3 ohm. Okay, so let us say that the power across the 3 ohm, what it will be right now.
IV. So it will be,
Power across 3 ohm will be again
oh,
voltage across 3 ohm into current across 3 ohm. Yes or no?
yes,
What is the current will be? That will be 10 divided by 2 plus 3. Yes or no?
yes,
Multiplied with the voltage, that will be again 10 divided by 2 plus 3 into resistance 3. Yes or no?
yes, sir.
Yeah.
So that will become, I think the first bracket you can see it is becoming 2 and 2 into 2, 4, and it will become 12 watt power across 3 ohm.
Yeah,
Yes or no? The
yes,
power
sir.
is
Yes.
becoming 12 watt. Let us choose the same circuit instead of 3 ohm, replace it by 2 ohm. That is the value of this R. If we'll do so, then what we'll get? The power across 2 ohm, that will be equal to this time the current in 2 ohm into voltage across 2 ohm. What is the current? That is 10 divided by
10 by
2 plus 2.
4. Yeah,
And again, for to calculate the voltage, I'm multiplying the current with the resistance value, that is 2 plus 2 into resistance, that is 2 ohm this time. Yes or no?
yes,
Sorry. Now what we'll get? Can you see that 100 and I think 16 here multiplied with 2? Yes or no?
yes,
It will be 100 by 8, and what the power that will become over here? That is I think 25 by
by 2.
4, not 25 by 50 by 4, and 25 by 2.
2.
So can you see what we got? 12.5 watt. Is this clear to
Yeah,
you people?
yes,
So
Yes.
have you seen this? That we are getting the power maximum at 2 volt. Okay, okay. One may say that, sir, you are choosing somewhat lesser value. That is why you are getting the 12.5 ohm. Let us, if we choose 1 ohm, that is even less than this 2 ohm. So maybe possible that even we get a higher power. So let us do it for that also as well. Okay. So replace the 3 ohm in the above circuit. Replace it with 1 ohm. Let us analyze it. We are going one ahead the boundary condition and one lower the boundary condition. Even if we get the not the maximum value there, the somewhat lesser one. So we'll be convinced that yes, this is the maximum one. Okay, yes or no?
Yes.
So 1 ohm will be again what it will be? It will be somewhat 10 divided by
Mm.
10 divided by 3 plus 1.
yeah,
This is the current, and again divide by for to in order to get the voltage, what we'll do? 3 plus 1,
3
that is
plus
the
1.
current, into resistance, that is the 1. Yes or no?
Yeah.
So 10 divided by 4 into 10 divided by 4 into 1, it will be I think 100 by 16. Yes or no?
Yes.
yeah,
That will be if we divide it by 4, what we'll get? 25 by
25
4.
by 4.
And what it will become? 4 6 are 24, 25 4 6.125 I think.
Yep.
yeah,
Okay, so can you people see that for those we are getting somewhat lesser power? If we even if we choose higher the value, even if we choose lower the value, we'll get the power to be maximized when this 2 ohm will be equal to that one. Okay, is this clear to you people?
So,
Yes or no?
yes, sir.
yes,
Okay, let me ask you a question a little bit tricky. Okay, this is the element of interest that I'm connecting over here. Okay, and let's say this is the capital R. This is 2 ohm and this is the 3 ohm. In order to get the maximum power, maximum power should get delivered to this capital R. What should be the value of R should be chosen?
The voltage,
What should be the value of R should be chosen in order to get the
So
maximum?
what is V, sir? Like what is the battery voltage?
Don't you think that V doesn't matter here? Only the
mm,
value of resistances are mattering for the
Yeah.
for the condition of maximum power dissipation. So whatever the V you choose, that doesn't matter actually. The power always used to get transported in terms of the ratios of the resistors. Okay, not the
Yes.
directly ratios, but actually the square one. Okay, so what should the R I should choose in order to get the maximum power should be delivered to this R?
So it will be two,
That will be
two,
actually the 5 ohm.
5 ohms.
That is, we can see from this that if there is a resistance, we want the maximum to get delivered to this 3 ohm. So we'll choose this resistor in such a way that it should become equal to this one, the remaining resistance. This clear to people?
yes,
So
sir.
if we want
Yes, sir.
this, so this capital R should be actually equal to 2 plus 3, that is equals to 5 ohm. Is this clear to you people?
Yes.
Yes.
Okay, let me ask you a reverse way. Maximum power delivered to 3 ohm. So what should be the value of R chosen? If I want the maximum power should be get delivered to this 3 ohm. 3 ohm should get a maximum power. Then what should I choose this value of this R?
Sir, R is,
Yes,
so will it be like 2 plus R, whatever the
yes,
value
that will be
is.
equals to 2 plus R equals to 3 ohm this time.
Yeah.
Okay,
So R
so this
is,
time R you have to choose as 1 ohm
oh no.
so that this together constitutes the resistance value of 3 ohm. This maximum power does not mean that this maximum power actually means that whatever the value the maximum will be get transported to this R. Okay, if you will calculate the power of some another value at R or taking some another value of R. For example, if you want to calculate this 3 ohm power, calculate the power of 3 ohm at taking the different values of the R. You will get the maximum power is being delivered at R equals to 1 ohm. Okay, so these types of questions are sometimes being asked of the maximum power deliver. So these are something the easy one. Okay, so that's all about this. Okay, so here we actually ends our chapter of the current electricity, and now you can solve any questions from anywhere. Although the assignments that I'm giving it to you, just complete it ASAP. It does not have a good number of questions. I think it is very few of them. Okay, and I think most of it I had already given it to you. Only few of them would have been left. So just I'll give it to you today. So that's all about our today's class. If there is any doubts in the today's class, then you must ask, or else in the next class we'll start our next chapter. That is what which chapter you people want? We should start. We had decided actually, na? That is
Yeah.
ray optics, I think.
Yes.
Okay, so that will start in the I think in the next week. Okay, so that's all about the today's class. If there is any doubt, you're most welcome, or else you people can leave now.
Yes, thank you, sir.
Thank you, sir.
Okay, welcome. You're welcome.
Thank you.
Yes, is it audible, Atiya, Mariam, Sanidhi?
Yes, ma'am.
All
Yeah.
right. Okay then. So yes, good evening, class. Yesterday we completed with a variation of acceleration due to gravity. If my voice breaks in between,